Hello and welcome to Mathletics with Sir Nawaz. Today we are going to start the topic of functions that is part of both O-level and IGCSE Mathematics syllabus. So let's start from the basic. A function can be defined many ways, but here is the simplest one, that it is a mapping from one non-empty set to another non-empty set such that every element of first set must have a unique image in second set. So this is known as the function criteria. It comprises of two conditions. The first condition say that every element of first set, every element of first set have an image in second set. While the second condition say that the image should be unique. The image of every element should be unique. Unique means that one element should have only one image. No element can have more than one image. If an element have two images or more than two images, that will not be considered a unique, so it will not be a function. So let's explore an example. Here we have two sets A and B. The elements of A are 0, 1, 2, 3 and 4, while the elements of set B are 0, 2, 4, 6 and 8. And we can see a mapping between the two between the elements of two sets. We can see 0 is mapped onto 0, 1 is mapped onto 2, which means 2 is the image of 1. Similarly, 2 is mapped onto 4, which means 4 is image of 2. In the similar manner, we can say that 6 is image of 3 and 8 is image of 4. So these elements are known as pre-images, while the elements of second set are known as images. All right. Now we have to check the conditions. Do they fulfill the condition of a function or not? First of all elements of first set are mapped onto the elements of second set. That is true. First condition is fulfilled. The second condition was that every element should have a unique image, and we can see that every element of first set have only one image, so the image is unique. We can see that there is a function between these two sets, and when there is a function, we can name it with f, g, r, h. It with f. It can also be named as g, r, h, r, etc. Right? So I will write it as f from a to b is a function. Now if it is a function, so the two sets will have now names. The set A is known as domain, while the second set is known as codomain, or sometimes we also call it range, but we will discuss it later in detail. All right, the first set here will be named as domain, while the second set will be named as codomain. Or we can also say the first set is known as the set of pre-images and the second set is known as set of images. Okay, so let's explore another example. We have an example where the set P comprise of elements 0, 1, 2, 3 and 4, while the set Q have elements 0, 1, 4, 9, 12 and 16. Now let's check that if it is a function or not. We can see that 0 is mapped onto 0. Similarly, 1 is mapped onto 1, 2 is mapped onto 4, 3 is mapped onto two elements 9 and 12, and 4 is mapped onto 16. The first condition is fulfilled, that every element of first set have an image in the second set. But the second condition, that every element should have unique image, is not fulfilled, because we can see that 3 have two images. The image of 3 is no more unique, so we'll say that it is not a function, right? It is not a function, and we'll give the reason as because image of 3 is not unique, it have more than one image. Another one, like we have two sets, the set X have elements, it have 2, 3, 4, 6 and 8, while the set Y comprise of elements 4, 9, 16, 25, 36, 49 and 64. So these are the two sets. Now check the criteria of the function. The first criteria, the first condition was every element of first set must have an image in set B, and that is correct. Every element of set X have an image. All right. Next was the images should be unique, and we can see that every element have only one image. Each element should have only one image, so it is a function. All right. We can see some elements in the set Y which are not images of any element, but that is not the condition on the second set, right? It was a condition on first set that every element should have an image. Okay, so that is a function, so I can name it as f or g. I will name it as g. So g is a function from x to y, is a function. Next, we can say that the set X is domain of G, while the set Y will be known as codomain of set G. Now we discuss the types of function. A function could have many types, like we can have algebraic functions, exponential functions, trigonometric functions, hyperbolic functions, and many more as well. But in our syllabus, we will only discuss the algebraic functions in detail. And what are the algebraic functions? Algebraic functions are mainly the functions which can be expressed as the algebraic expressions, like f of x is equal to x plus 3, or it can also be written other way, f of x is equal to x plus 3, also written as f such that x maps onto x plus 3. All right, what does it mean? That here x is the input, while what is the output of this function? X plus 3 is the output of this function. All right, so if I take an input of, let's say I take the input of 5, x is equal to 5, then what will be the output? The output will be 5 plus 3, which equals 8. So it will be written as the function was f of x now replaced by 5 will equal to 8. F of 5 is equal to 8. So that is how the functions are dealt with. Like we have example, and the second example, which was g of x equals x square. Now we explore its some values. Like first I say we should find g of 2. So it will be definitely 2 square, which is equal to 4. Okay, the second one, it say the g of minus 5. So it will be definitely the square of minus 5, which is equal to positive 25. So that was the g of negative 5. Similarly, we can have many other operations on the algebraic function, which we are going to discuss in detail in the coming video. So